Hi everyone, welcome back to Random Accessible Maths. I'm Dr. Ramchurn, and in today's lesson we'll be learning about negative numbers, also known as directed numbers. So, what do we mean when we say directed numbers? Well, we're talking about a direction, and therefore with a direction we'll need a line, in this case the number line, to show us which direction numbers can go in. So, let's do a simple example. If we have 7 take away 2, we know this operation means 7 subtract 2. Now if we visualize this with a number line, we can show that we start at the number 7 and we move backwards by 2 spaces. So 7, 6, 5. So this result is 5. Now, if we were to reverse this subtraction, so we do 2 take away 7, we can do it in the exact same way. We draw our number line, start at the number 2 and count backwards by 7. 1, 2, 3, 4, 5, 6, 7. And 2, 1, 0, minus 1, minus 2, minus 3, minus 4, and minus 5. So this has taken us into the negative section of the number line. 2 take away 7 is minus 5, or negative 5. So you'll notice that when we swap the subtraction, so 7 take away 2 is 5, and 2 take away 7 is negative 5, the number is the same, but the sign has been flipped, or has become the negative of what it was. So that's a tip you can use to help you with difficult subtractions that go into the negatives. So let's write down this rule that if you have A take away B, you can swap it and do B take away A, but you'll have to make sure your result has a minus sign in front of it. And this can help you do difficult subtractions. So let's take a look at some examples of that. Okay, our first example, we have 50 subtract 13. Now this should be relatively easy to work out. Even doing mental maths, we can work out that the result is 37. So what if we were to switch the subtraction and instead ask what's 13 take away 50? Well, using the knowledge that this is 37, we can know that this result is minus 37. Now, how about 10 subtract 24? This one might be a little bit more difficult, but if you work out 24 take away 10, which is 14, we know that this result should also be 14, but with a minus sign in front of it. So if you have trouble where the number to begin with is smaller than the number that's being subtracted, you can swap the order, work out the result, and then put a minus sign in front of it. Now, if we go back to the rule where we had A minus B equals the negative of B minus A, you'll notice that we have the minus sign outside of the result. Well, if we look at this and know that this is minus 14, then surely if we were to put this inside here, we can use the result where we take this result and put a minus sign in front of it. In other words, we have two negatives next to each other, minus minus 14, which is the same as positive 14. So this rule will be useful for dealing with negative numbers and operations with lots of minus signs in there. So let's take a look at some examples of that. Okay, I have 4 examples on the board where we have the 4 combinations of positive and negative signs. So let's start with 5 take away minus 7. So you'll notice that this minus minus has been written without the bracket that we saw in the previous example. Yet the rule is still the same. Because there are two minus signs touching or next to each other, this is equivalent to 5 plus 7, which results in 12. Now you can think of this as something like 5 subtract negative 7, as in you're starting with a positive 5 and you remove negative 7 from it. If you remove something negative, that's equivalent to doing or adding something positive. So if you want to think of it like that, that might be easier. Now let's take a look at the next example. 5 add negative 7. So if we have 5 and we have negative 7 and we put them together, well, the negative 7 is larger in size compared to the 5. So effectively, the result should be negative. And actually what happens is, if we have a plus and a minus touching each other, the rule is that they become a negative. This result will be the same, 5 minus 7, which is negative 2. In the third example, we've swapped the plus and the minus, but it's still the same result. 5 subtract positive 7 is just the same as saying 5 subtract 7. So just like the one above it, that results in minus 2. And for the final example, 5 add positive 7 is effectively just 5 add 7, which results in 12. So these are our rules. Two minuses next to each other make a plus and a minus make a minus and a plus make a minus, and two positives or two pluses make a plus. So this is how we can rewrite more difficult directed number questions to help us answer them. Now, a lot of times you'll see that there's brackets in front of the minus number after the operation. That doesn't make any difference here. The minus minus will still make the plus, and the plus minus will still make a minus. So we should also understand that this number 5, which has no sign written before it, we assume it to be positive. So there's invisible plus signs in front of every single positive number. We don't normally write them down because in maths we don't need to write down if we don't have to, or we like to make things as simple as possible to write down. So let's take a look at an example with some minus signs in there and see if you can have a go and solve it. Okay, so here's the challenge. Try to simplify this expression. So if we take a look at the double negative, this minus minus, we can convert that into a positive or a plus, and this plus minus can also change into a negative. So this is now minus 7. This should be easier to simplify, so let's start from the left and work our way to the right. And because there are only minuses and pluses, or additions and subtractions, the order doesn't matter, as we learned in BidMaths. So minus 40 and 32 make negative 8. And then we take away 7 from that, so we result in negative 15 for our final answer. And let's not forget our equal signs to make sure that we're showing that these results are all equal in value. So hopefully you got that correct. Now let's move on to other operations with negative numbers. So in these examples, we'll take a look at what happens when we try multiplying with negative numbers. And the rules are pretty much the same as we saw for the addition. Essentially, two minuses make a plus, is the shorthand way of saying what we're about to do. So, in the first example, we have negative 5 multiplied by 4. Well, we know what 5 multiplied by 4 is. That's 20. So, if one of the numbers is negative and the other number is positive, that's basically the minus and the plus put together, which create a minus number. So this will be minus 20. The second example, 7 multiplied by negative 2, is essentially the same thing. It's positive then negative multiplied together. The brackets are only there to emphasize that the minus belongs to the 2. But if 7 multiplied by 2 is 14, then this must be negative 14. And for the last example, negative 10 multiplied by negative 3. This one is like the two minuses together, creating a plus. So a negative number multiplied by a negative number is a positive number. And we know 10 multiplied by 3 is 30, and this is also positive 30. We could write the plus sign, but as usual, in mathematics, we don't need to write down the positive sign because that will make it more complicated, and we like to do less writing. So, that's multiplication. Well, the same rule would essentially hold for divisions. So, if we were to do negative 35 divided by negative 7, and we could put brackets around both numbers to show that the minuses are with those numbers, this would essentially be the same as 35 divided by 7, or two minuses make a plus. So this result should be positive 5. And if you were to rearrange and bring this negative 7 to the right hand side by multiplying both sides by negative 7, we would find that indeed minus 35 is 5 multiplied by negative 7. So the rule is still the same for the division and the multiplication. If there are two positives, it's a positive result. One positive and one negative is a negative, and two negatives make a positive. Now, for the final tip, I will show you with fractions, since division in Key Stage 3 and beyond, we don't normally have division symbol, we have fractions. So there are a few ways of writing down the same number, as I will show you now. Okay, this number on the board is minus a half, minus 1/2. This result is exactly the same as negative 1 over 2 and 1 over negative 2. All three of these have the same result of negative 0.5 if you want to write it as a decimal. You can do the working out. 1 divided by 2, you can do a long division and show, in fact I'll quickly do that now, how many 2's go into 1. 2 into 1 is 0, and the remainder of 1 is carried over to the decimal place, and then 2 into 10 is 5. And all that's changing is that we have one of the numbers as a negative, which means that the final result is also negative, minus 0.5. So, hopefully this helps you rewrite some more tricky expressions, and hopefully this video has helped you out. If it has, please pass it on to anyone else who you think would benefit, and please leave a like, comment and subscribe, and I hope to see you in a future video. Take care.